Mixture problems involving percents. Imagine you have two equally sized containers. One is pure water, and the other is 50% water and 50% juice. If you combined them, what percentage of the mixture would be juice? Let's draw a picture. We have two containers. One is just water, so it's 100% water. The other is half water and half juice. I want to know the final amount. What percentage would be juice? So let's first figure out what we're doing. We're going to be adding one container that I'm representing with green to another container that I'm representing with blue, and it's going to give me a final container that I represent with orange. So we have to think about that relationship, that addition relationship, and we need to represent it. We need to take into account the size of the containers as well. So the containers are the same size, they're equally sized. One of them is pure water. So I'm going to label this 1 unit. I could also label it 100% if I wanted, but let's use 1 unit for now. It's 100% water. I have another container. It's the same size as that first one, so I'm going to label it 1 unit as well. It's half water and half juice. The third container is going to be those two added together. So it's going to be twice as big as that. These ones were each 1. I'm going to say that my third one is 2, right? Because I don't know how much each of these containers held, but they're the same size. So this one's got to be twice as big as that. We want to know what percentage of the mixture would be juice. So I'm going to say X is juice. Let's go back and make one quick edit. You see this first container? I labeled it 100%. That was the amount that was water. We're measuring juice. The percent of that container that's juice is 0%. So when I write my equation, I'm going to have to involve that 0% somehow. Remember from before, I said that my green value plus my blue value would be equal to my orange value. So I'll do the same down here. Now I can build an equation. I know that of my first amount, I took 1, but 0% of it was juice. So I'm taking 1 times 0 to represent my first container. To that, I'm adding my second container. It's the same size as my first one. And half of it is juice. When I add those together, I get a container that holds twice as much, so that's where this 2 is coming from. And I want to know what proportion of that container is juice. So there's my equation. Now I just need to solve. 1 times 0 is obviously 0, so that disappears. 1 times 1/2 is 1/2, and that's going to be equal to 2x. To finish solving, I'll need to divide both sides of my equation by 2. And that gives me x equals 1/2 divided by 2, which is 1/4 or 0.25. And therefore, 25% of my final mixture would be juice. Let's take a look at these next 3 sections of this same question. If a 2-gallon container of pure juice is added to 3 gallons of water, what percent of the mixture is pure juice? We don't actually have to work that hard to answer this question. So we know that we have a 2-gallon container. So I'm going to represent each gallon with 1 circle. All right? So I've got a 2-gallon container of just juice. And then separate from that, I've got 3 gallons of water. and I'm going to mix them together. I want to know what percent is just juice. Since they're pure water and pure juice and not mixtures to begin with, this is actually kind of an easy problem. So each circle that I draw is going to represent 1 gallon. So there's 1 gallon of pure juice. Here's another gallon of pure juice. And then I'm adding that to 3 gallons of water. So remember that those are all mixed together.
Claire Russell to the main office. Claire Russell to the main office.
Sorry about that. So what percent of the mixture is pure juice? Well, 2 out of the 5 are pure juice, which is 40%. So we were able to do that with pretty much just pure reasoning. Let's complicate it a little. B, if a 2-gallon container of juice mixture that is 40% juice is added to 3 gallons of water, what percent of the mixture is pure juice? So we could approach this in the same way if we wanted. A 2-gallon container of juice mixture that's 40% juice is added to 3 gallons of water, and we want to know what percent is pure juice. Let's use our circles again, each to represent a gallon. So these guys, these are pure water. The first two are 40% juice. So each of those are 40% juice and therefore 60% water. So this part's water, this part's juice. If this is enough to get you started, feel free to pause the video at this point and try to approach this problem on your own. However, I am going to keep walking us through it. So, these circles over here, there are 2 of them, and they're each 40% juice. So I have 2 sets of 40%. So I'm going to take 2 times 0.4. These ones, there are 3 of them, and they're each 0% juice. So I'm going to take 3 times 0. What I was doing here was I was taking the juice mixtures and adding them to the pure water, and then I was going to get some sort of other mixture that was more water than juice compared to these guys. So that's what I'm doing here. I'm taking this mixed amount plus the pure water, and I'm getting some other unknown amount that's got all 5 of these gallons. So remember that each of these was a gallon. So we had our 2 gallons represented here, 3 gallons represented here. This blue has to represent 5 gallons. So 2 times 40% plus 3 times 0% equals 5. We don't know what percent we're talking about, so let's use x. And there's my equation. I know it's kind of spread out right now, so I'll rewrite it to hopefully help us. Looking at 2 times 0.4 plus 3 times 0 equals 5x. So when I solve that, 2 times 0.4 will give me 0.8. 3 times 0 gives me 0, and that's equal to 5x. Well, 0.8 plus 0 is just 0.8. So I end up with 0.8 equals 5x. To finish solving, I'm taking 0.8 divided by 5, which is 0.16. So that means that 16% of our final mixture is pure juice. All right, let's step on to number 3. If a 2-gallon juice cocktail that is 40% pure juice is added to 3 gallons of pure juice, what percent of the resulting mixture is pure juice? So now we're looking at it in kind of the other direction, and I'm going to change my colors just so I don't confuse us. We've got a 2-gallon juice cocktail that's 40% pure juice. And then separate from that, we've got just 3 gallons of juice. And we want to know what percent of our final mixture is just juice. So I'll draw circles to help me. We have 2 gallons of juice cocktail. So 2 gallons represented here of juice cocktail, and that's 40% juice. Remember what I'm doing is I'm taking that and I'm adding it to just pure juice, and I'm going to get some other mixture. So my blue plus my orange will equal my purple. To that, I'm adding 3 gallons of pure juice. So these 3 gallons are 100% juice. My purple, I don't know, that's what I'm trying to figure out. So some percent of it, I'll call it X percent. Here's what I know. I know my blue plus my orange equals my purple. And I also know that I have 2 gallons of blue mixture, 3 gallons of just juice. So overall, that gives me 5 gallons of my final product. I have enough information now to write my equation. I've got 2 sets of 40% juice, and to that, I'm adding 3 sets of 100% juice. And when I do that, I get 5 sets of some percent juice. And now you have enough information to solve. You've got 2 times 0.4, which is 0.8, plus 3 times 1, which is 3, and that's going to be equal to 5x. So that gives me the equation 3.8 equals 5x. To finish solving that, I'll need to divide both sides by 5. When I take 3.8 divided by 5, I end up with 0.76 equals x. So our final mixture is 76% juice.